I'm Anil Kumar, and in this video we will learn different methods to solve exponential equations. Let's begin with a very simple example, and let us say we have 2 to the power of x equals to 8. How can we solve this equation? Now x is in the exponent, it is an exponential equation. We can write 8 with the base 2 and power something, so that we could write 2 to the power of x equals to 8 as 2 to the power of 3, right? 8 I have written with the base 2 and exponent of 3. Now, since their base are same, we can say x is equals to 3. That is one way of solving exponential equations, right? Let me do it once again with kind of a different example. Let's take 3 to the power of x, and let me write down is equals to 1 over 27. Now the idea here which you've got is I have to write 27 with base 3 and some exponent. So I could write that as 1 over 3 to the power of 3. 3 cube is 27. Or I can say that is equals to 3 to the power of minus 3. So if you compare now, so we have 3 to the power of x, let me write here, as equals to 3 to the power of minus 3. So we get x is equals to minus 3. Now this is a very effective way of solving exponential equations. You can always, if possible, write both sides of the equation with the same base and get your solution. Now you can do a question like 5 to the power of x equals to 125, get your answer. You could have, let us say, 2 to the power of x equals to 1024, right? So let these be the questions for you to practice. Follow the same strategy. You could write 125 as power of something, 2 to the power of something, and then equate the exponents. So that way we can actually find solution to exponential equation. Well, there are times when it is not so easy to write with a whole number. So if I give you equation as 4 to the power of x as equal to 8, in that case, how are you going to solve it? Now, of course, I cannot write 8 with 4 base and then some power. What I can do in this situation is that I could write 4 as 2 square. So I'll write 4 as 2 square. So x is already there. So it becomes 4 could be written as 2 square to the power of x, or 4 to the power of 2x. And on the other hand, I could write 8 as 2 to the power of 3. Now I get same base and exponents are 2x and 3. So my solution will be 2x equals to 3, or x is equals to 3 over 2. So that is my solution. 4 to the power of 3 over 2 is 8. Square root of 4, let us check. So we are saying here x is 3 over 2. That means square root of 4 and then cube it, right? So square root of 4 is 2, right? So we get 2 cube, which is indeed 8. So it works. Do you see that? So at times you may have to go down a step and then get the solution. I hope you're getting the idea, right? So as a practice, let me take one more example here. So going with the same trend, we'll say 9 to the power of x is equal to, this time let's write 27. So you can solve this equation. You can write 9 as 3 to the base something, and 27 3 to the power of something, equate, right? So you can solve it. For example, here 9 is 3 square and already x is there. So 3 is 2x, and this becomes 3 square cube. So now 2x is equals to 3, x is equals to 3 over 2. So that is how we could solve it. I hope you understand and appreciate how we could solve these kinds of exponential equations. Correct? Now at times what we can also do is make it a bit more complicated. We'll say, well, now we'll have 4 to the power of, let us say, x minus 3. So we are putting something else in the numerator, and instead of 8 we have another number. Let's take 32. I know if I would have taken 16, it was simpler, right? So we are combining the strategies learned, and let's say 32 also we write to the power of something, correct? And then we'll try to figure out what that something is. Okay, for now I'll keep it as such. Anyway, so we'll write, as you understand from this strategy, 4 could be written as 2 squares. So we'll go in steps, 2 square and then it is x minus 3. Okay. 32 could be written 2 to the power of 5, correct? 2 times 2 is 4, right? So we can use the calculator at times. Okay, so we have 2 to the power of 5 equals to 32. So you can figure it out, what power will give you that base. Now since we have the same base, we can compare the exponents. We have 2 times x minus 3 equals to 5. Solve the equation. So we have 2x minus 6 equals to 5. 2x equals to 5 plus 6, which is 11. X equals to 11 over 2. So that becomes the solution for our equation. Do you see that? So at times the exponential equations could be solved in this manner, right? Now I'll take another type of exponential equation where we'll have powers on both the sides. So let this equation be 2 to the power of x plus 3 equals to 4 to the power of, let us say, 2x minus 5. I have 2 as the base. Let me make 4 as the base with 2. Then I could write this as 2 to the power of 2 times 2x minus 5. And here I have 2 to the power of x plus 3. So we get an equation which is x plus 3 equals to 4x. We'll just multiply and expand, minus 10. Bring x's together, numbers together. So we get 13 equals to x on that side makes 3x. So x is equals to 13 over 3. So we could solve this equation in that particular fashion, right? So I hope you understand how we can solve exponential equations using these strategies, correct? So that is how we could do it. And now what we can do is we can take a bit more complicated cases. The complicated cases means sticking to these things. What I'm trying to say, I'm just thinking whether introduce you to logarithms or not at this moment. Okay, so what I will do here is I will introduce you to logarithms. So let's get back to the equations which we started with. So I'll keep this as my part 1. Okay, so as we have seen so far, most of the time we were in a position to get something to the power of something and equate the same base. But always that may not be possible. For example, if I tell you 2 to the power of x should be 9. Now, how to solve this equation? Well, what I know is that 2 to the power of 3 is 8 and 2 to the power of 4 is 16. So 9 is somewhere in between. So one method is I could estimate 2 to the power of 3.1, 3.2, 3.3 likewise and get a value which will give me 9. The other way is using logarithms. So I'll introduce you to the technique of using logarithms, right? And solve exponential equations. So what we can do at this stage is when you are not able to perform operations which we have learned so far, you can take log both sides. So we say log of 2 to the power of x equals to log of 9. I'll provide you with the link so that you understand the connection between exponential and logarithms. And also when I write log like this, the base is 10 and we can use calculator to find this answer. And one more log rule says when it is log of 2 to the power of x, I could write this as x times log of 2, which is equals to log of 9. Now I can isolate x and can write x as log of 9 divided by log of 2. And using calculator, we can calculate this answer. So let me show you once. So it is log of 9 equals to divided by log of 2 equals to, we get answer as equal to 3 point, let us say 17, right? 1699. So that is the way you could use logarithms and find. Estimate, as I said, is not a bad option. You would also do 2 to the power of 3.1, 3.2 and then converge to this answer. That could be possible. You get my point? So now you can use logarithms and try a few questions on your own. let me give you the question here as 3 to the power of x is equals to 10, right? So try it out with logarithms. Similarly, you can try with 5 to the power of x equals to 20, right? So we know 5 square is 25, so it has to be less than 2. So there are times when this strategy of using same exponents may not work, and in that cases we use logarithms, right? So there could also be few other cases when we give you some complicated equations where the bases are not the same, right? So there also you have to use logarithms. So that is how you should be doing it. Now as a practice question, let me give you few questions. I have given these kinds. Amongst these, let me write down some questions for you. So what I'll do is I'll write 9 to the power of x minus 3 or plus 3, whatever, plus 5 let me write. And then I'll say 27 to the power of x minus 3, right? So I just made one equation for you. Now it is not necessary that these equations may have solutions, right? Most of the time you hopefully will get a solution. So you can try this. Now in this equation it is better to write both in terms of 3's, correct? So that is how you could do it. Well, we could also at times give you equations with radical signs. For example, if I write 4 to the power of x is equals to, let us say, fifth root, and this is 7, right? So I could write an equation like this. This is also an exponential equation. Try to find solution of this particular equation from the techniques which we have learned so far. So all the examples which I am giving you at present, you can actually solve them without logarithms. I have introduced you to logarithms, giving you an idea that all equations cannot be solved by this method, but we'll explore more of this in the next video, right? And we'll also learn the properties of logarithms before getting in there. I hope that helps. Thank you and all the best.